Hello, my name is Peter van Zandwijk. I work with the Netherlands Forensic Institute, and in this half hour I will tell you about some research that we did on the health app of the iOS, and then you can go to lunch. So I did this research not alone. I worked together with my colleague Abdul Bostas, who helped me with a lot of the experiments. And the most important thing that I want you to remember from this presentation is that the health app registers both steps and distances. And we have found that the accuracy of the steps registers is much better than the accuracy of the distances registered. What are we talking about? So the iPhone health app is a system app which is shipped with the iPhone since iOS version 8. And if you look at it, then it's this one with the heart. And if you open it, then what you get to see is this menu. So it stores a lot of information, and it falls also in a broader category of all kinds of health-related applications, which are both available at iPhones, but also at other kinds of telephones. So the part we are interested in is in this area. So it registers information about all kinds of daily activities that you do, and it does so automatically. It also stores other things about even things like reproductive health. I don't know what you want to register about that. But the things from a forensic viewpoint that we are interested in is within this daily activity. So if you click on that one, when it opens, you see it stores 3 different kinds of things. So it stores number of steps, it stores distances that you travel, and it stores also the number of flights, the number of stairs that you go up and down. So these kind of things. And if you, for instance, click on number of steps, then what you get to see is some detailed information. So you get aggregated number of steps over periods of days, in this case. So you can see on which day we did the experiments. It must be obvious from this one. And if you click on one of these days, you even get more detailed information. So this is number of steps with time periods in the order of 1 minute that you get. And if you do that for distances as well, you can also get the same detailed information. Now, of course, this is from a forensic perspective very interesting information, but if you want to use it, then you must have some idea about the reliability of these kinds of information. First, a quick word about the forensic use. So yesterday we also had an interesting workshop about probabilistic reasoning in forensics. So in what way could you use, if you know something about the accuracy, this type of data? Now, for instance, you can try to make a probability statement about several distances. So if in one case you have 2 scenarios, for instance, one scenario in which the distance excuse me. This one. Oh, this is very bad. I guess this one. We have a scenario that the distance is 100 meters or that the distance might be 250 meters. Then you can try to make a probability statement about the likelihood of the traces that you find in the telephone under the assumption that the distance was 100 meters, and also the likelihood of the traces that you find in the telephone under the assumption that the distance was 250 meters. And another one is also if you have several scenarios which might have things that might have happened in the case, then you can also make similarly a probability statement. How likely are the traces that you find in the health app under the assumption that the first scenario is true or that the second scenario is true? So those kind of things, those kind of probability statements can be made if you have some idea about the reliability of this information which is present on the iPhone. And finally, of course, it can also be used as an indication that the use of the telephone was still active, was working, and didn't die already, for instance. So it can also be used as an indication of physical user activity. Now, of course, we're not the first ones to think about it. So there have been some, at least in the Netherlands, there have been at least 2 high-profile cases in which this data from the iPhone health app was used as evidence in a case. And also, As I noticed in Germany, there was a high-profile case in which data from the health app was used. In that case, they used the number of flights because the question is whether somebody traveled up some stairs. So that this was a kind of rape murder case in Germany. So the people from the Netherlands will recognize this one. It was a very high-profile murder case in the Netherlands. Also, in that case, the suspect made some detailed statements about what had happened during a time period, so it could be matched against the data from the health app to see whether it matches or. So this was one. And finally, this was a case in America. It was not the iPhone health app, but it was a Fitbit, so it's another kind of health-related application. So this was a kind of wristband that you can wear, and in this case, it was also a murder case. And then the husband, he had a murdered wife, and in that case, he claimed that somebody raided the house and she was killed, but data from the Fitbit indicated that during the period that he said that his wife was killed, there were still some steps or distances registered, so that disproved his story. Okay, so the main question I will address in this presentation is about the reliability of the number of steps and the distances which are registered in the iPhone. And our approach is to do experiments and then compare what we find in the telephone to the ground truth. So we used fixed routes, so we know what the real distance is, and we compared it to what was found in the telephone. And we also manually recorded the steps. I will show how we did it, and then we compared it by the things that we really found in the telephone itself. So in that way, you get a feeling about the reliability and also the factors that influence the accuracy of the device. Okay, so we used 3 different telephones, an iPhone 6, a 7, and an 8. We had one subject. We had the telephone at different locations, so we put it in his trouser pockets. We put it in a backpack. We put it in a jacket pocket, high, and put him in the hand, and also put it in a low jacket pockets. And finally, we gave him one of those things that flight attendants also have, so manual that enabled him to manually count the number of steps. And we also had the experimenter walk together with this, so we had a second manual count of the number of steps. So this is what we did. Finally, we had, so this is a part of the premises of the NFI in the Netherlands. So we had a forensic archaeologist. He has very good specialized equipment in order to determine the locations of certain points. So we had him trace out a route. So we exactly knew the location of these numbered points. And on the basis of that, we could define some walking routes. So we had we always started at the first point, and then we had a route of about 100 meters, which ended at a clear landmark. So you could also always see that you ended at the same position. So we had one of about 100 meters. We had one of about 250 meters. And finally, we had one about 450 meters. So we had 3 different distances that all the subjects had to walk. So to sum up, I got a number of colleagues who are willing to participate. So we had 5 subjects walking with all these telephones. We tried 2 different walking speeds. So we tried normal walking, and then we tried some freely chosen running pace in order to see how that influences the accuracy of the device. As I said, we had 3 different distances to see whether that was also a factor influencing. And as I showed you, the telephones were carried at 5 different locations. Now, we wanted to have some good statistics. So for each combination of walking speed, distance, and carrying location, we asked them to walk the distance twice to see whether the registrations actually match to one another. So that was really quite some work. So in total, all the subjects, they walked about 600 trials, which amounts to 130 kilometers. So a lot of us got a very good walking condition. And manually, we counted about 450,000 steps using the counter. Now, during the trials, we also manually recorded the start and the end time of one specific trial. So you can see it here. So, excuse me. We recorded the start time and the end time, and also the number of steps which were recorded by the subject using the clicker. And we did that because the digital part of this research is a little bit limited, but nevertheless, I will show you there is some database on the device itself which stores all the information about the health app. It says it's healthy-based secure, but it's not secure. It's just a SQLite format database which you can pull off using commercial tools, and then you can get the data out using standard SQL commands. And if you look in the database, so this is the information that we extract from the database, then what you see is you get information about the start time of a registration and the end time of a registration. So this is the database ID. And you get information about the number of steps and the number of distances. But what you see is that it can happen that, so these are the timestamps, and this is the number of steps registered and the number of distances registered. But what you see is that if you have a long trial, then there can be several registrations corresponding to the same trial. So the only thing that we had to match afterwards is, and that's why we used this form which has the start time and the end time of the trial, then we had to match the registration in the database to the actual trial. So in this case, we had to compute the total number of these registrations which are spread over several timestamps in the database. That's the only thing that we had to do offline. And then we got the total number of steps and the total distance, and we could compare it to the actual values that we measured ourselves. Okay, so concerning the number of steps, then we get this graph. So the data for all the 3 telephones that we used, for all walking distances, for all walking speeds, and for all carrying locations together. And on this axis on this side, it is the number of manually measured steps, and this is the number of steps which are registered by the telephone. And the black line indicates when both are together, then all the data points will fall on the black line. So in this case, you see there's a very strong correlation between the actual number of steps and the number of steps which are registered by the telephone itself. So we tried to quantify this a bit. So we computed what is called the mean absolute percentage errors, which sounds very complicated, but only is the percentual deviation of the number of registered steps with respect to the true number of steps. So, for instance, if you take 100 steps and in the telephone there are 110 steps, then the difference is 10 steps, and you take that as a percentage of the actual number of steps. So in that case, the error would be 10%. So that's also. And then you average over all different trials, you average over all conditions, and what we find is that this average error is about 2%. So here you have for the 3 different telephones that were investigated, and it's always about 2%, so that's pretty good. So to come back to the main message which I showed you at the start of the presentation, so on the basis of the data, I hope you would now believe that the number of steps registered by the telephone are accurate. Unfortunately, for the number of distances registered by the telephone, the situation is somewhat more complicated, because in that case it does depend on several other factors, like walking speed and the style of walking of the subject, for instance. Now, in order to show that, I will show you some data. In this case, this was the iPhone 7 that we investigated. In this case, the telephone was worn in the trouser pocket. So on this side here, you have our 5 subjects, each time repeated. And there are 3 groups which correspond to the 3 different distances that we had the subjects walk. And the green line indicates the true distance that we measured. There are bars which are blue, which means the distance which is registered by the telephone when the subject is walking. And the red ones is the distance that is registered by the telephone when the subject is running the same distance. So in this case, you can clearly see that for all our subjects and for all our distances, the telephone registers a larger distance when the subject is running compared to the distance which is registered when the subject is walking. Now, another example is this one. So this is the same telephone, but in this case, the telephone was held in the hand during walking. And so this is the same. So the subjects are over here. The blue one is walking, and the red one is running. So what you see in this case is that there's one subject. Let's see. When the subject is running in this case, then there's an enormous larger distance which is registered by the telephone. We attributed this to the walking style because this was somebody who used to do something at athletics. So when he was running, then he started to swing his arms very much, and we clearly see that affects the distance registered by the telephone. Okay, so this summarizes what I've just said. So we see there's a large spread in distances registered by the telephone. And sometimes the distance is larger when you are running, like the first example that I've shown you. And sometimes the distance is larger when you are walking. And also we see that there can be large differences between subjects, which we attribute to the walking style of the subject. So if you walk in a different way, then you can also get different registrations. Unfortunately, I only did show you some data from the iPhone 7, but for the other two telephones, we got very similar results. Okay. We also computed, like for the number of steps, the average percentual accuracy of distances. And what we notice is that the distance registered by the telephones are more often too low than too high, but there's a large spread which can go up to 30 or 40% of the true value, which is significantly larger than the error that we found in the number of steps, which was about 2%, as I've just shown you. Okay, so we were really puzzled about this large spread in distances registered by the telephone, and we came up with some hypotheses which might explain the reason why these distances are sometimes larger. For instance, if you have it in the trouser pocket. And our idea was when the telephone performs a larger forward-backward motion, then for some reason the distance registered by the telephone is larger. Which would explain, if you have the telephone in your trouser pocket, if you run, then there's a larger forward-backward motion than when you are walking. And also this subject which swung with the telephone in its hand has a larger forward-backward motion. So that's one of the hypotheses that we formulated. And in order to test it, we had our subjects perform some additional experiments with the telephone in the hand. So normally we didn't give any instructions about the way that you should keep your hands during walking. They could do it the way they liked. But now we specifically asked them, go walking and keep your hands as closely as possible, like this. And after that, we asked them, go swing as much as possible. Go back, like this. And then we compared the data from those experiments to the ones in which there was no instruction given concerning arm movement. And from that, we get this picture. So this is the same. So the subjects are over here. The blue ones are the distances registered in walking, and the red ones are the distances registered in running. And the additional ones with the triangles are the single trial that we got when the subject was swinging his arms like this, as much as possible. And the black ones are the distances that are registered when the subject was instructed to keep his arms as much as still as possible. So you see in this case that the distances follow the same trend. So if you are swinging with your arms, then you get a larger distance. And if you keep your arms as still as possible, then you get about the same or sometimes a less distance. So we take this as another confirmation that indeed the forward-backward motion of the telephone is an important factor influencing the distance. So this summarizes, but of course we are the Netherlands Forensic Institute, so we should be a bit careful. It was only one additional trial that we had the subjects make, so, but it can be taken as an indication. And it seems to point in the same direction as I just said before. So to come back to our main message again, so I hope I could convince you that, or I already did, that the number of steps are accurate up to about 2%, and now the distances registered by the telephone, excuse me, they are influenced by a number of factors, and they can deviate about 30 to 40%. But if you take that that shouldn't be a problem to use it for forensic, but you should be aware of these peculiarities of the health app. So if you want, as I showed you before at the beginning, if you have a scenario in which one distance is 100 meters and the other one is 200 meters, then on the basis of this data, you can make some probability statement. But if the distance is 100 meters for the first scenario and 110 for the second one, then the spread is so large that it will not be very meaningful. Okay, so once again with the NFI, so one caveat. So one very important point is that we investigated the situation if when you are walking or running, how accurate are the steps that you get. So, and it doesn't imply from if you get steps and distances registered in the telephone, it doesn't need to imply that some running or walking has taken place. You can also have other reasons why you get registered distances and steps in the telephone. For instance, if you drive in a car over some traffic bumps, you can also get some registration. And if you shake the telephone, you can also get it. But if you know there is walking, has been walking, then you can use this data in order to estimate the accuracy. Okay, I mean, we have now we really did our best to produce data, but it's of course still a bit of a limited data set. We had 5 subjects, and we see that we also saw there are individual differences between subjects which affect the accuracy of the distances, for instance. So you have to be a bit careful. Okay, so this was our main part of research. At the moment, we are working with our forensic statistics group in order to see when we can develop some statistical model. So use our data to develop a statistical model which can be used to estimate number of steps and distances on the basis of traces that you find in a telephone, and also get some estimate of the spread that you can expect in that case. Of course, we are hoping to keep our data set up to date because continuously there are new versions of iOS and also new versions of iPhones coming to the market. So we really have to put some effort in to keep our data set. And also, if you get in case, we will soon start analyzing a case in a telephone that we have not analyzed, so we have to do that over again. And it would also be very interesting to investigate other kinds of health-related technology which contain a lot of information. For instance, we did not do any experiments with Apple Watch or with Samsung or Android telephones or some third-party apps. It might also be very interesting to have a look for it. But at least I hope I was able to convince you that these health-related apps, and more specifically the health app on the iPhone, has some potential to be used as evidence in forensic casework. Okay, that's what I had to say. Thank you very much.
Thank you. Did you think about, like, if I take a walk, I will walk 100 steps from, I'm here.
Oh, okay.
Yeah. Yeah. From time A to time B, and then I walk 100 steps. Yes. Then I set my watch or my time on the phone back and start walking again. Would you see 200 steps during that 5-minute period of time, or would you see 100 steps, and would the app rewrite itself in the database and say, oh, I have updated my timestamps, or would it just increase the timestamps or the steps?
That's a very interesting question. We didn't do that, but I would expect you would get 2 kinds of registrations with the same timestamp. But yeah. I don't know, because we didn't do that kind of experiments. But sometimes some strange things might happen with those kind of things.
Thank you for an interesting presentation. I'm from the University of Leiden Applied Sciences in the Netherlands, so I also, with great interest, followed the case, the murder case. So I remember that Apple responded, maybe in a general sense, that they don't think their health app is can be used as forensic evidence.
Yes.
Did they actually approach you, or was there a discussion going on between NFI and Apple? Because this clearly shows that you can make some conclusions about it.
Yeah. So no, we actually, in one case, we formally asked Apple for a statement about whether we could use the data of the health app for forensic purposes, and then we got the answer that you just summarized it.
Okay.
So they said something like, we do our best to make our products as reliable as possible, but it depends on different factors, and you shouldn't really use it for forensics. That's the kind of response that we got. Yeah. But we didn't discuss these results with Apple.
Okay, yeah. Thank you.
And do you have any idea how the distance is computed from the steps in the health app? Because I mean, there must be some formula or algorithm to do that, and obviously they're not using GPS.
No, that's a very interesting question. Yes, I expect that because the number of steps is very accurate, so there are all kinds of sensors in the telephone. For instance, accelerometers and gyroscopes. And I think it's very easy to detect steps from those accelerometer signals, because you get some spike in acceleration when your foot strikes the ground. And on the basis of that, I suspect that they make some dynamic estimate of stride length, and then they multiply the number of steps by this estimate of the stride length in order to get the distance, something like that. But how it exactly works, that's still a complete mystery. Yeah.
Following up on his question regarding stride length, were the same participants using the same phone where maybe the stride length calculations would have been differentiated by participants? I'm not sure if each participant used a separate device or if it was the same device per participant, and if those profiles might have been askew by differences in stride length between different participants.
No, we used the same telephones for different subjects, but the experiments were done on different days.
Okay.
So that,
thank you.
Yeah.
Have you tried to collect the data from Apple Watch? It is probably more accurate. Yeah. Probably not. I have no idea.
No, I saw in the program there will be some presentation about collecting data from Apple Watch, but it's possible to synchronize or include the Apple Watch into the health app as one of the sources of information.
Yeah, exactly. It is being synchronized, but it goes to the same health database.
Yeah, so it can use several sources of information together. So that would also be very interesting to see whether the distances become more accurate if you use both the health app and the Apple Watch together.
Yeah, we have to try.
Yeah. Daar. Mevrouw.
Hello, thank you very much. It was very interesting. It's easier than others, or it's very interesting. I just want to recommend the subject of the participant. I want to just classify, for example, the woman who has the short leg, or the participants can be the child. The distance is a little different.
That's one of the points I didn't mention in the presentation, but within the health app you can also put in your own body measurements. So in the main series of experiments we didn't put any body measurements into the app, but after that we did a smaller series of experiments in which we actually put in the length of the subject and the weight of the subject, and then we saw some small changes.
Okay, thank you.
Yeah.
So, thank you again.
Yeah, okay. Okay, thank you very much.
Very interesting presentation.